Hello and welcome back everybody. Welcome on this Friday stream. And today we are going to continue our work with our monitoring tool for the RoadRunner, and I'm as always I faced with super weird issue with my NeoVim configuration. Let me I'll describe you about this issue right in a second. Just needed to close all of these windows. Let's go to our test where I faced this issue, and let me open the Twitch monitoring tool. Done. Okay, so super weird problem. Yesterday I was surprised why I'm sorry guys, forgot to need to answer, sorry. Okay, so I created a like simple test where I just put a string. You may see it here, like string, and then like push A and B into the string. So it's like easiest test as you can imagine. The next thing I did, I put a breakpoint here on the line number 471. And let's start our debugger. So let's choose 6 numbers. So this is test number 5. And let's continue. As you may see here, we don't have any local variables initialized yet, yeah? Because simply we don't have them. Then when we step out one step, we see our string. Then we see the string have A and the next string have B. So the case in this issue was that I use the previous version of code LDDB to debug all of the things. So everything is fine with if you are using like GDB tools like LDB directly with your binary, but it's hard to to debug tests. It's not hard, but you can like you should like run cargo test and choose a specific test to to run. But with the latest version of Cargo LDB, all of these values are empty. So it's very easy to realize that somewhere were errors like during all of this setup. But I just used this extend header. It's my method, and I extended header from the incoming binary stream. Yeah, and if you get here, you'll see that so we can extend header basically in Rust two like standard ways. So extend from slice and pass a pointer to a slice, or extend and just use data iter. So from iterator. And first I like realized that okay, so I guess something is wrong with my method. Yeah, so because I didn't see the new data appended to my existing slice, yeah, existing vector. And I was like, okay, so might be something incorrect, maybe some value destroyed, or so borrow checker just so value dropped during the lifetime overlaps, some kind of things. But I quickly realized that it can't happen because obviously we use Rust. So if we have a data with a lifetime less than our header, for example here, so obviously we'll get an error of like incompatible lifetime. So value dropped, why it's still used, yeah, and will be dropped here on this closing bracket. So then I started to investigate, because it's okay. So keeping in mind that DAP, all of these plugins are just clients, like NVIM DAP, NVIM LSP, and etc. All of them are clients, and so fun case here is I realized, so what can be wrong in this setup? So where you can't see, even if you use like REPL, for example, like this, be like self header. Can I use? No, there's no such. Okay, so maybe I can use it like P. So a lot of errors, as you may see, still exist. And yeah, PV2, CodeLDB, yeah, so errors. I don't care about REPL, by the way. I care about the thing. And as you may see here, so all of these values becomes like 97 and 98, yeah. So becomes a different representation of the value, like ASCII codes. So, and I was like, so what's wrong with my setup? I start to digging into all of the plugins once more time. So where is the issue? And then I started to debug with Visual Studio Code. Like, let's try the Visual Studio Code and see if it's like properly handles the requests. And Visual Studio Code as well handled all of these requests like this DAP client. So because obviously Visual Studio Code is just a client, like in Vim DAP in NeoVim, yeah. And so I started digging into the server, like debugger, and debugger I use here is let me show you. This is from Visual Studio Code. It's called CodeLDB, but this is just a wrapper around the LLDB debugger to like pre-print all of the. So yeah, just wrapper to have a nice representation of Rust values, for example, or Rust types. And so okay, what if we try to use CodeLDB directly without like all of these wrappers? And it works. It works fine. So I use GDB and LDB, and all of these debuggers works fine. They are so I have to use like pretty printers, but so generally all of them work fine. Yeah, and so then I realized it's something with CodeLDB, and yeah, I tried the version 1.9, yeah, and version 1.9. So as you may see here, as represented in this in my bug report, so you can't you don't see S even when you on a println line, yeah. So I just, why me? So why me? Why I every time I start digging into NeoVim, I faced with this super weird issues or super weird releases with the bugs. And even if you may see here, if I use CodeLDB with this wrapper, but directly with the REPL, so as well I can see, I see nothing, but should see A and B, and I started to do the most obvious thing which you start to do when you see an error like this, just downgrading versions and bisect the commits to search where is the issue. And I found that the reason of this problem was update of LDB, yeah, and reported to the upstream. And downgrade my version to 1.8.1. So if any one of you sees all of this issue in your configuration. So keep in mind that that you need to downgrade your code of the version to 1.8.1. Okay, so that was like pretty good debugging experience to debug the debugger. You know, I don't need this anymore. Right, and let's go to our Naivia tool. So Naivia is our actual tool to where is my code? Tree-seater. Why I can't highlight my code? Okay, it's better now. Good. So yeah, and why I faced with this issue, by the way, when I read the data here from the stream, from our RPC request, so I realized that okay, we have a frame, yeah. And when we extend our header with the data we received from this network protocol, so nothing appeared in the actual header. So what's happening? And that led me to all of this investigation. Okay, so what's happened with the protocol recently? I added, so I don't need basically to do this. I just need to extend a header like this. Extend header. And we actually don't need to be mutable because we're still passing an iterator. Okay. So what's happened here? We need. Oh, let me open let me open the actual server, which is written in Golang. I'm sorry. So I added a logic to handle our protocol reading. So let me explain how it works. So we have 12 bytes. So every time we start reading our frames from like where we communicate between our services, so every time we read 12 bytes. 12 bytes is a base header which represents the data which comes later. Yeah. And we might have 12 bytes of the header if we don't have an options, and in this case header length would be 3. If we don't have an options and have a header length 3, we don't need to read options from not the actual data, but reading options and append these options to the header. So in this case, we don't have options. We just skip this step and calculate, get the payload length from a header and reading the next chunk of the data, which is equal to payload length. And then we have. So we have inside our payload, we can have a context and we can have an actual payload. So context can be passed and can be, for example, if we have a HTTP request, yeah. Who is barking? So if we have HTTP request, for example, and we have headers, HTTP headers, HTTP, data, proto, and etc. So it can be a context, and payload can be a body, yeah. So we also split this data inside the payload. But in our case, when we pass options in case of RPC communication between. Oh, by the way, let me open our super diagram. Yeah, so this is super diagram how the plan to be working. Yeah. we have a Go application and we have a protocol Go by default, which works with Go and Go applications, and we have a Rust like application and Go application. So with Rust application we have and we trying to communicate via an RPC, just plain RPC, without like JSON RPC, like gRPC and etc. So just RPC. Okay, and okay, and the first read, we're reading from this protocol 12 bytes of the header. 12 bytes. I'm the worst painter in the world. 12 bytes, and this 12 bytes represents our header, like 0, 1, 1, 0, 0, 1, 1, 52, 52. We can, what useful information we can get from the header? We can get, for example, if we have an options. Information about, do we have an options? We can get information about payload. Thank you, plotted dog protein. I don't need this. Okay, and we can have a payload here, and which is more important, we can have a like CRC zoom to check if our like header is valid, and then based on the information about the payload, for example, we can payload length. For example, we get that payload length is equal to like 10 megabytes. We can safely read with only one chunk these 10 megabytes, so without like reading and iterating by megabytes, so producing a lot of system calls. We basically mimicking here approaches like buffers, you know, so we don't need, so we can read any amount of data with only 3 system calls if we have headers, but in most cases we don't have them. And with 2 system calls, yeah, if we don't have them. So just read the 12 bytes of the header and read the rest of the payload. Yeah, but in our case we have a header length, and that means that we need to read how to calculate how much bytes we need to read to append to our header. It's easy, because header's length represented in U32 numbers. That means that if it equals to 1, it means 1 for byte word. And if it means like 5, you know, 5 times 4 is like 20 bytes of additional header is coming. Yeah, and here we, if header length is, I'm sorry, more than 3, we just subtracting header length and 3 from header length to calculate actual data, how much bytes do we have, and multiplying it by 4, so we have like 4 by 4 by 4, which means like words, and then reading this data and extending header with this data. The next step is to read what is a payload length actually. So, and then the last step is just, you know, to read our payload and to distinguish actual payload in our like method we called like sequence ID and etc. So, and yeah, marshal, unmarshal, parse our payload, our message from this payload. So it's like sounds complicated, but it's just so a lot of like read operations. Okay, let's put a breakpoint here and let's start our debugging. Because it's main package. Okay. So, oh, we haven't correct. What? Hello from Go. We call this method. Read extend header. Oh, let me check. Do we have? Oh yeah. So when we we need to replace a header, not extend it. Read frame header. Yeah. So initially header is equal to 0, yeah, like empty, and we don't need to extend it, so because we append unneeded data to the header. Okay, let's slightly update our logic. We need to have a header let header is equal to read frame header routable, and header is equal to buff. I think this should work. Yeah, header is like pointer, and we dereference it and replace the data inside it. Only one thing. I think that our protocol would be incorrect in this case. Okay, let's see. Okay, what is our header? 21. But it can be 21 because it should be only 1. Oh, CRC passed. We sent 21 from Go. Why? Okay, as you see here, hidden length is equal to 5. Yeah. So we need to, and here you may see 1. It's like a first word for like 4 bits. And unit 32, and second word, which is equal 15. 15 means offset. All of these are offsets, like sequence ID and offset to read method. Okay, read payload len is 29. Yeah. Read options len, and payload start from offset 15. And full from Go. Hooray! Yeah, we did this. Okay, so and let's just continue. Naivia and cargo run. Payload full from Go. This is super cool. And so now, as you may see here, we successfully created a bridge between Go and Rust via plain RPC. So you can achieve this by packing all methods with protobuf, but since you do need somehow to know the size of the payload which you should read, you should use either like delimiters or end of files, like read until end of file. But still, while you if you have this kind of communication, so you'll produce a lot of system calls, to read the data. How we can read exact? Oh yeah, I guess I can do the following. Oh my god, so I'm so bored of this, all of these errors, and like, so as you see here, so this DAP UI debugger still prevented me to type. I don't know, that was reported as a NeoVim issue, but I still can see. So read frame, header mode. Read frame, header mode, mutable, and actually don't need this buffer at all, and yeah, we don't need all this. Oh, sorry. Yeah, so only one thing we need to do is to just read exact amount of data. Okay, so like this. Let's modify this approach. Oh, connection refused. Let's see. Data header. Yeah. So we read all the data. I'm just slightly curious why it says from Go like header size of the header version 21. So it's kind of surprising. Why it's 21? But let's check. Somewhere inside the RPC. Write response. Oh yeah, somewhere here in write response. Write version. Yeah, it should be. Oh, is this like? Yeah, this is a 1. And why it's represented as 21? Okay, actually, this doesn't matter at all. Let me just check one thing. Cargo run. Yeah, everything works fine. Hello from Go, and we sent exactly this message from our Go counterpart from this RPC. Done. So RPC with our custom protocol is done. So it wasn't super complicated to do, but yeah. So we use protobuf here, and the most complicated part of this communication protocol is that Rust doesn't have standard proto tool to compile like protobuf files. Yeah? I don't know why. Google Rust proto. Why Google? Google protobuf compiler list. Other languages. Yeah. Yeah, so they have for C++, C#, even Dart, Go, Java, PHP, but nothing about Rust. Google, are you just out of your mind? I don't think it's too, complicated to translate C++ into Rust. With their amount of people and so on. By the way, does the protobuf dev is official site? I don't think so. Yeah, C++, Java, Objective-C, PHP, Ruby, no Rust. Where's Rust? Where is the issue about Rust? Rust support request. Rust support request. 2019, guys. 4 years ago. Official support for Rust. Duplicate. That probably would never happen. Yeah, so that probably would never happen. yeah, probably. Half a decade later, I'm spinning up the official protobuf implementation for Rust. Cool story, yeah. Yeah, so if it's like February 15th this year, I don't think it was too far away from this Rust implementation, so having standard protobuf compiler for Rust. Yeah, from Google as well. Create skeleton for Rust backend. Oh yeah. Okay. So let's see, it's for the version 23. Oh yeah, they recently changed their release, let's say, versions like Kotlin, other. Okay, so we'll be waiting for this. Let's give it a while. Okay, so the complicated part of this implementation was to create, to properly compile the protobuf thing in Rust. So I used this project called Rust Protobuf. Yeah. Okay. So what's next? Let's try to do the following. Let's try to call actual RoadRunner endpoint. Yeah? Why not? Let's create oh yeah, so we also need to create a crate. Let's create it and call it RPC. And mod rs, and let's create my god, why I still have this issue? So when I just can't type, you see, like I type M, I'm trying to type M, but I can't because it's like started to be resets into normal mode. So this is not an OSP, yeah? This is not an OSP program. Tab stop. This is not tab. Let's see the version of this. Oh, why it's like... This is the wrong version. Let's compile the new one. So, since this is quite easy to compile, you know, any version of this tool. I'm sorry, this tool. I called NeoVim this tool. Of NeoVim, yeah. By the way, while we're waiting, let's do the following. Where's OBS? Oh yeah. Let's bounce this bot. Bam. And let's install. Oh yeah, now 0.10. Okay. Now should be everything should be okay. Yeah, so we have this I'm sorry, generated this is our test message, and let's so RPC create will have will accept an RPC stream and yeah, and produce an actual message and a method. Maybe it should be a separate method. No, it should just only have two methods, like send a data and read the data. So it's like request response, or just send and yeah, just send. And so return value would be a result of the data of the message. Yeah, it should be like generic as well. So trade it should send a data. And client TCP come on. it's not ready yet. I mean it's not ready. It's like Rust network is not ready. Oh yeah. I forgot to do this. std-net TCP stream and a payload which is T and return so since we have request and response, and there are different messages. Why it's not? Oh, it should be included. Mod RPC. And result. So it can be vector of bytes or an error like this. So we're going to send some data, have a client. So why we accept the client from outside is because we need to have we might have different addresses. Yeah, we can have basically we can have a single client, so we don't need to have it here, and we can accept in new function. Address, it should be as ref. T as reference. Oh. What it should be? E0 E107. Yeah. So what is the issue here? Oh. Sorry, it should be like this. So inside new we pass an address, yeah, to our underlying client, and then we just needed to we would need to send we also needed to have a method. And method can be an enum. For example, it can be version. Like this. So actual method is method in our case represented by, like, for example, test method. Yeah. So we need to provide this method to actually see what data we wanted to receive. Yeah. And let's implement, and let's struct let's call it RPC. We would have client stdnet TCP stream. Yeah. We should have we also should have sequence ID, which should be U64. And so it can be just reset on if it reached to maximum number, it can just be reset to 1, so no problems with this. Should it be async? I don't know. Might be, can be async. We don't have async traits at the moment. I don't want to use this attribute async trait. Okay, so let's implement request for RPC. Fn send fn new. And let's do the following. Let mute client is equal to stdnet TCP stream connect address. And we can return an error in this way. It can be like this. Result self and stdio error like this. Consider restricting silver set. Okay, what is the problem here? Oh, yeah. Okay, let's then T is not documented. Let me check. Should be okay, so let's finish this. We need to have then we need to return RPC structure, which will contain our client is client and sequence ID will be 1. So initial into okay, yeah, we can use short ones. Okay, what do we have? What should return receive? I'm sorry. Address. Oh, to socket address. Yeah. So I used the wrong generic name. Should be not as ref, but to socket address uses the network. Oh, yeah. Not here. Here, yeah. Remove this generic undefined type T. Okay. Generic trade Rust. Pub trade iterator. Yeah, so we have generic here. Oh yeah, I got to. Trade defined here is on generic parameter. With one generic parameter. Where's generics? Yeah, for the functions easy, like what about the structure and implementation? as is display. T is to socket address. Oh yeah, import request T to socket address for the RPC T. Add missing generic argument. Trade request. Try defined here with one generic argument, with one generic parameter, and cannot find type T in the scope. Yeah, because I'm just slightly confused. How? Okay, we have a trait. Yeah. Then say hello. Intro to generics. Yeah, we have a function, this one, using trait. Say hello, yeah, this is easy, like easy example. So basically we can have, yeah, we can have any number of type parameters here, like m can be mapper plus serialize. What about traits? Trait this. Should be after impl. Oh, can do like this. Okay, got it. So my issue was that I forgot to add this type parameter, sorry. So okay, now seems fine. Let's see if we have an errors. Cargo build. No, we don't have an errors. And let's put our logic of parsing our frame to this send. To the send method. So what we're going to do this here in this method, we're going to create a frame, yeah, with the default argument, write a version to the frame. So we later I'm going to write a doc about this, and then this is our payload. So we should have here like bytes payload, and we should payload, and we should combine this byte payloads with method, like method plus payload. And that would be our actual payload, yeah, like payload with method. And yeah, we also should append to this like binary stream. We should also append a sequence ID, yeah, which is here represented by this one number. Let it be actually. Vector reference to the vector. Oh yeah, we also should use a frame. Should add our use directives for the frame. Okay, so here we are writing init frame plus add a version. Next step is to payload already represents this message, yeah. Write flags. Frame write options. Self sequence ID and payload length. Oh, options are actual. Oh, this should be U32. Yeah. Okay, so we wrote an options, and next step I want to have all methods represented as enum. So because we have like limited number of methods, and so not to guessing what are the actual methods, so would be I think would be cool to pass this versions not versions, methods as enums, yeah, or constants, for example. We also can use constants. Yeah, I guess it's not enum. No, let's try enum. And method display macro Rust. I guess we should implement it by ourselves. Impo std fmt display for method. What method we should do? Oh yeah, fmt. And we would have only 0 number of arguments, and yeah, the string. Okay. And we would have this toString method. But actually, display is fine. Impo toString. toString where you what is this? Yeah, we can actually use display. Be fine, so no problems. Okay. Then we needed to combine our method name and an actual payload. Yeah. So since we wrote options like sequence ID and payload length, we already know the offset of our payload. Yeah. And the rest we need to do is to just combine the method to the payload. So since we know where a payload starts, so we can just subtract from the beginning of the stream and get our offset of the of our actual data and our method name. Okay, and it should be like frame right payload and how to do this? Let mu tmp is equal to vector tmp extend. This is not a slice. So method actually should be a vector. It can be a num, or like, you know, we can write impl to vector, impl to vector, like how ras to vector. Where's this? Input. Just for vector. Try find struct vector not to train. 2. How to improve this? We can convert in place, you know, all these things, but I want to do like, you know, Rust way. Oh, yeah, we can do into, yeah. example into vector of bytes for method. And okay, how would we convert our self? So I don't know about how it would be as terms of API, how it would be that fine or not, because so I guess passing just a method would be super cool here as an option, yeah. And okay, let's try the following. Back self string bytes chars let's see. Oh yeah, we can use this ugly method. This is like vice versa operation. So I need to convert vector into. Oh no, I don't need string from. Oh, super cool. String as bytes. Oh, we have this method as bytes. Oh, cool. As much types expected struct. Oh. So temp is do we need to expect reference false? Oh, so okay. We need a reference. As much type struct found unit type. Oh. Oh, maybe we should do like this. Oh yeah. So vector, so extend from slice doesn't return anything. So yeah, we need to do like this. V extend from slice and then V like this. Yeah. looks super ugly. I don't know. I'm not super, you know, super duper pooper Rust professional, but for me it looks like it's even worse than if error not equal to nil in Go. Okay, let's go temporarily with this. And then what we need to do. We need to have a method into a vector of bytes. And then extend it with our payload and then iter. Okay, we don't need this. We don't need this anymore. Oh, by the way, I just put it into the main. Right, options. We already did this. Yeah, and the last thing to do is to write our frame. Okay, so then self client and write why no method name write all for the struct TCP. What? Just right? Oh my god, what's happening? Can find while above. Okay. Oh. Okay, and then self client. I'm gonna name it read exact. Why? Read exact. Okay, and the last step we need to do, so we can safely comment this out, and the last thing we need to return is our actual payload, which we can then parse into the message. Yeah, and this is this is our payload to vector. Okay, so last error try using fully qualified. What generics? Method takes 0 generic arguments, but 1 generic argument was supplied. What's... Turbofish. What is Rust Turbofish? No, it's not Turbofish. Yeah, this is Turbofish. What generics are you talking about? Consider moving the generic element to the into trade. Where I should put it? Rust, please stop. So this error is slightly confusing, I have to say. Cargo build. Expected 0 generic arguments. Where do I have this? This is not a generic. Okay. It's like UA. There's nothing related to generic. Oh, I guess. This is about into. Type must be known at this point. Info. The another info found in the core trait. Maybe I don't need to do this. What generics you are talking about? Maybe I need to use generic somewhere here in the input. Okay, let's do the following. Let's do the trick. I just want to see what's happening. Where is the trait? We don't have generics at all. Oh. It should be implemented differently. Try using fully qualified. What is surprise? Oh. Again, we should have. Interesting how it should look like. Quite interesting. Oh yeah, this is a famous Rust error. Temporary value dropped while bored. Yeah, so should we use like self to string as bytes? Yeah. We do need mutable here. Okay, so here, so I'm just quite surprised why we need this method as into, because we have implementation of into vector for the other things here, or what? I guess I need to read something about this. So what's happening here? We are converting our into. So as far as I understand, we are converting our method into the vector of bytes, yeah, and extending this vector with our payload. So should be fine now. Okay, let's try then. Okay, let's try to uncomment all of the things. Okay, let's try to use our super library. Where is our... I start the server. let R is RPC. Oh, they are, yeah, they're private. Oh, okay, that's okay. RPC. It's implied from the structure, as far as I understand. Oh, this is request. Why I can't use RPC? Oh, by the way, I also wanted to derive default. Default is not implemented for the stream. Yeah, we can't construct it actually. We can put it into the option to default would be none in this case, but okay, let's skip it. Can I construct? Yeah, you can construct this. Because I wanted to call method called new. So we can construct a method. Oh. Oh yeah, we need lifetime. We have to put it all into the heap. zigzag. Test method, yeah. What is going on? I guess I don't need to use toString since we implemented display, right? Yeah. I guess we called a recursion. I guess we trapped in the recursion error here with self. Yeah. No, it looks like everything's fine. Has overflow its stack? No. Actually need to do this. Can we just derive it with this macro? Yeah, for the there's no string. Yeah, type annotation needed. So returning to this annotation and this connotation to oh, self into oh yeah, this is ours. No, what is that? we can't use this into, because actually, so we implemented into on this structure to convert it into the vector, yeah? So we can't use it obviously, because it would be recursion. Okay guys, I'll think how to fix all of these errors. I guess we slightly slowly moving to the our implementation for the RPC. So RPC is a very important point here that we needed to implement before we actually start to implement everything related to WASM and Rust, all of this and HTML, all of these GUI things, because RPC calls to RoadRunner is the basing block for our API actually. So we do need to have the data which we wanted to display. So okay, so that's it for today, I guess. As usual, have a super awesome weekend, have a good Friday, and see you next week. Bye bye guys.